All right, in this video we're going to look at finding derivatives of inverse trig functions. Now, the textbooks are like 50-50 on how they write this. They will either use the inverse -1 exponent or they'll write it with arc. So if I look at this first example, you could have easily been asked to do it could have been written like this, so arc sine instead of that sine inverse. This is the older way to do it because it was back in the days when it was difficult to have books published that had that inverse up there, when all they used were typewriters back in the olden days. So I'm just going to go ahead with this inverse symbol. Okay. Now, if we're going to do that, then what I need to do first over here is to have a little list. Okay, we're able to see that. Okay, this is typical of, say, a final exam where you will have a list of formulas, or you might have a mean professor that makes you memorize these. But these are the common derivatives of inverse trig functions. Okay, so what we're going to do is we're going to go with this form, and we're going to take the derivative of both sides with respect to x. So the derivative of y with respect to x is going to be dy dx. And then the derivative of inverse sine, well, I'm going to use that stock formula, but I don't have inverse sine of x. I have inverse sine of 3x squared. So the derivative of that is going to be 1 over the square root of 1 minus, and then what goes in parentheses there is 3x squared. Okay, then times the derivative with respect to x of 3x squared. Okay, so it's kind of using the chain rule. So I'm going to have 1 over the square root of 1 minus, and then 3x squared all squared is going to be the same as 3 squared times x squared all squared, which is going to be 9 times x to the 4th. And then the derivative of 3x squared is going to be 3 times 2x, which is going to be 6x. And so I'm going to have dy dx, or y prime, it's the same thing, is equal to, then I'll write that as one fraction. I'll get 6x all over the square root of 1 minus 9x to the 4th. So that's the answer for my first one. Okay. All right. All right, so now I'm on to the next one, and this one has been written with as arctan, and so we have y is x cubed, and that's the same thing as the inverse tangent of e to the x. Okay. And again, I'm going to take the derivative of both sides with respect to x. So the derivative of y with respect to x is dy dx. And here I've got the product rule. So if I differentiate with respect to the product rule, it's going to be the first part of the product times the derivative of the second part of the product and then plus the second part of the product times the derivative of the first part. So I'm just using the product rule there. So I'm going to have x cubed, and now the derivative of the inverse tangent function, I'm going to use this template, but I'm going to be replacing that x in there with what's in the parentheses here, e to the x, and then I have to multiply this by the derivative of e to the x. Okay, and then I get to this one, and I'm just copying inverse tangent of e to the x, and then the derivative of x cubed is going to be 3x squared. Okay, and so I'm going to have, now the derivative of e to the x is just e to the x. So I'm actually going to multiply that out the front. And e to the x squared is just going to be e to the power of 2 times x. So the rule is you multiply those. So I'm going to write that all as one fraction. So the numerator, I'm going to have e to the x times x cubed. And in the denominator, I'm going to have 1 plus, and then that will be e to the 2x. And then I'm going to have plus, and I'm going to bring that 3x squared out the front, and then inverse tangent, so times inverse tangent of e to the x. Okay, and I'm just quickly checking what I worked out before. So that's a correct answer. And again, another textbook might not write it with the inverse tangent. It might write it as arc tan. Okay, so however your textbook does it. All right, so that's equally a correct answer. Okay, to the last one. Okay, so on this last one, it's written with the inverse here. It could have been written like that. Okay, so some textbooks would write it up like that. We're going to go with this. Okay, I'm going to have to use the quotient rule here. So if I take the derivative of both sides with respect to x, I'm going to have dy dx over here is equal to, and the quotient rule says it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, then all over the denominator squared. Okay. So I'm going to have x squared there, and I'm going to have x times the derivative of inverse cosine. Okay. Minus, okay, now the derivative of x is just the number 1. So we're having inverse cosine of x times 1. Okay, now that's certainly a correct answer, but we need to make it pretty. Okay, it's not pretty. It's not a simple fraction. We've got a fraction in the numerator. So if I multiply that x through here, I'm going to get that. This is not how you would see it, though, in the back of the book or on a final exam multiple choice selection. So how am I going to make that into a simple fraction or a simple rational expression? I need to get rid of this fraction. How do I get rid of a fraction? You multiply it by the denominator. So I'm going to multiply this by the number 1, and I'm going to choose to write 1 as that. So what I've written there in red, that's not changing anything. So I'm going to have, all right, so in the numerator, when I multiply square root of 1 minus x squared times this term, they're going to cancel, and I'm just going to be left with minus x. Then I'm going to have minus, and then inverse cosine of x times square root of 1 minus x squared. And then in the denominator, I'm just going to multiply those together, x squared times the square root of 1 minus x squared. Okay, and so you don't want to ruin it by trying to make it, you can't take that x squared and multiply it through a square root. And so that is actually the correct answer. Another book would just write arc cosine, arc cos instead of that inverse there, but that's our answer for that one. Okay, so that concludes all 3 examples. We made it to the end, and thanks for watching. I'm Dr. Sooze, and check out my channel on the tube. Lots of other videos, and hopefully they can help you with topics in calculus and algebra, statistics, trigonometry, lots and lots of different types. Thanks for watching.